All right. So as you can see, I'm going to be presenting on the Go programming language. And that there is the typical Hello World example that you see for every language when you first see it. Go is a language that started at Google that is a C-like language. They describe it as a systems language. The reasoning behind it being that it there hasn't really been a new systems language designed recently, and they wanted to take that syntax and modernize it and add in a lot of new features for the way things are going with concurrency and multi-threading and that sort of thing. So right from their FAQ, when you ask why is it named Go, and their response is Ogle would be a good name for a Go debugger. And no other explanation besides that. So I guess they just took Google and split it up. But it was created by Rob Pike and Ken Thompson and a couple other folks at Google back in 2007. In a nutshell, it's a C-like language but modernized, and I use C-like lightly because when you start looking at the syntax, they've actually changed quite a bit in a lot of different things, and so you'll be seeing that in the slides here. It's also statically typed, garbage collected, concurrent, and the great thing about it is it compiles very, very quickly, and that's something they've focused on very heavily. All their different decisions they've made as they were designing the language and what to include and exclude, build times were always something very close, very, very frontwards in their minds as they were building it to make sure it would compile. Another great thing about it is package management. It's just built in and you don't really have to think about it. You just give it a URL to a Git or Mercurial or Subversion repo of the package, and it handles all of that for you. And it compiles down to native code, so you can run it wherever you can run native code. It was open source in 2009, and there's a very active open source community around it. There's been a lot of momentum around Go recently, which has been really nice. I guess you could say it's a breath of fresh air after seeing what open source has been like in .NET and not very active or enthusiastic. And then you look at all the different open source projects available in Go, and it's eye-opening. They reached 1.0 about 2 years ago, and since then they've kind of locked it down so that they won't make any more breaking changes. Their focus is on compatibility. The only time they'll consider breaking is if they had to make a security fix. And they've talked about they don't really want to focus on Go 2.0 anytime soon, maybe in a few years as they let the dust settle from 1.0 and see what kinds of things they need to change or add. Right now it's at 1.2.2, and the 1.3 beta was released very recently too. So I'm going to go through all the syntax with these slides. This is kind of a little slide heavy. I'll try to go through them quickly and then we can get to the demos. But it starts with variables, and as you can see, the type declaration goes on the right, and that's always on the right. Everywhere you see any kind of type declarations in the language, they always go from left to right. You can also just leave off the type declaration if it can infer it. You can also do multiple type assignments and declarations on one line, or even multiple different types, which is pretty cool. And within functions, you can leave off all that extra junk and just do foo : equals or whatever to assign your variable really quickly and easily. So collections kind of follow the same format where it's going to the right. This is an array of 5 elements. There are a few other ways you can define that array if you wanted to leave off the size. Slices are the things you'd be using most often. So if you can kind of compare arrays to arrays in .NET, and then a slice would be the thing that is at a higher level, similar to a list in .NET, where it's a slice references an array, but it can grow and shrink, and you can chop it up in different ways. As you can see here, with this slice, I'm actually referencing this other slice, but only a certain amount of elements within that underlying array. And you're not copying the elements or anything like that. You're just dealing with another view of the data. So you can see there's a few keywords, or you could say built-in functions that deal with slices. The append is the way you can add elements to the slice and be able to grow or shrink it. Well, I mean, not shrink, but with append, you'd just be growing. And then you can also just create an empty slice with the make keyword. Make is used for a few different things in Go, as you'll see. And then if you wanted to copy a slice, they have actually a copy keyword or function that they've made for that. So you can kind of see it's a little more low level than you're used to seeing, where you're doing copies or initializing with a certain length or that kind of thing, rather than a more functional style collection that you've seen before, or a higher level list where it's a mutable object that you can just keep adding on to. In this case, you're just continuing to modify that slice. They also have maps, and the syntax here is not my favorite, but you get used to it. And it's also going to the right, as you've seen. So you declare the map and then the key and the value type. Maps can be created with make as well, and then you can set items on the map. You can also just declare all the maps in line, like you can with a slice or array, and you just provide the actual values as you declare it. And then you can read from it, and you can also check if it exists just by reading from it, all in one line, because Go has multiple return values. So here you can get the value and check whether it exists just by referencing that. And then to remove from the map, you can just use the delete keyword. Conditions, even if blocks in Go, have kind of had a makeover. There's no parentheses for their if blocks. You can also do, they call them short assignments, I believe, or short conditions, where you can declare some variable and then do your condition, and then that variable can be used within the if and else block. So rather than having to define this farther up and have several lines of code, you can do it all in line here. That's about one of the only places where you'll see a semicolon. Loops are also like the conditions where you're not going to have the parentheses anymore. And they only have one loop construct, which is for, and you can just use the for keyword for any kind of loops you need to do. So you can do the typical for loop, you can do a while true, similar kind of statement, just loop forever, just by saying for. And in all these cases, it's just another way of looping. So with that said, you can also loop over collections using a special keyword. So here's the standard way you could loop over a slice, just by using the length function to get the length and then going through them one by one. Or you can use the range, and that gives you something similar to a for each, where you wouldn't have to worry about getting each item out of that collection as you loop through it. Instead, it's just going to return both the index and the value to you at the same time, and then you can make use of both of them. Or you can loop through a range of for a map and get the key and value together at the same time. So this would output from this loop, Go has loops true, Go has generics false, just by looping through those two different values. Functions are pretty nice. As you can see, when you declare types, you don't have to repeat yourself when you have multiple parameters of the same type. Then you just declare the output type, and then you return your your response. You do still have to use the return keyword, so it's not like languages like Ruby or Scala where you've seen that it's just going to return the last line. So you still have to explicitly specify what you're going to return. But it does let you return multiple items and also name the returns variables so you can set them somewhere within your function and then return them when you're ready. So here's an example where I've created a function that does the divide and the modulus at the same time. So you can get both the integer division and the remainder all in one return. And because you can also do that multiple assignment on one line, it's a really clean way of just setting them both up. This is also an example of how you can export variables and functions just by capitalizing them. So that's built into the language that anything lowercase is only accessible within your package. Anything uppercase can be used from other packages. So more about functions.
How would you call divmod?
How would you call divmod? You know what? I'm actually going to show you that. We'll just take this and let me switch over here. So are you saying like what would the code look like that's going to use that? So I could do something like div mod : equals div mod. Let's say we're going to say 11 and 3. Actually, let me maximize that. Oh, div declared not used, mod declared not used. So I was going to get to this a little bit later, but another thing about Go is that there are compile time restrictions that you might not have in other languages that would normally just be warnings. So when you create variables that you don't actually use, or if you import packages that you don't actually use, it just makes it an error right off the bat. They have no warnings at all in their compilation, and their FAQ just says if it's important enough to warn about, it should just be an error. If it's not important enough to be an error, it's not worth saying. It's not worth saying at all. So it just have no warnings at all. It's just it either compiles or it's an error. So let me quickly throw in. Yeah. So I'm kind of using some features of Go Sublime, which I'll get to a little bit later, where I'm able to use the built-in terminal here to run. I just did an import package with some keyboard shortcuts. And there's a few other things that make it really nice. In fact, here are all the commands built into Go Sublime that you can do. Go to definition, viewing the help. In fact, let me show you that real quick right here. So I'm going to print line div and mod. Not sure why I capitalized div there, but now let's run that again. Okay, so now you can see, hopefully, yeah, div3 mod 2. And some of the cool features of Go Sublime, I can command.h that and look at the documentation for this function. I can even go to definition on it. And Go Sublime takes you right to the source code for it. So the plugin for Sublime for Go is really nice. Has a lot of cool features. Does that answer your question, Jack? Okay. Sorry, let me get to the right slides. Maybe. Did I lose my slides? Yes, thank you. Okay. So some more things about functions. They can be used as values, just like in JavaScript. You can pass them around, declare inner functions, call them within other functions, that sort of thing. So here's an example of a Fibonacci function that creates a closure to reset the Fibonacci sequence every time it's called. And then from here, it creates the function that I'll actually be invoking, and then moves through and begins printing it out. So you would see the sequence of values it would print out. And then the next time I actually call Fibonacci, it's going to reset and give me a new function with a new closure. And I'm only calling it once, so it just prints the first value. So you'll see nested functions quite a bit in Go. So Go is an object-oriented language, so you have structs. Something interesting about it, though, is that there's no type inheritance. So you wonder, how do you create objects and not inherit? And instead, what they have is implicit interface implementation, which I'll get to. To start with structs, you can define a struct. I'm just going to use a point with x and y coordinates. When you create the struct, you can pass in values, and these values just go in the same order of what you defined. Or you can give it named arguments, as you see here with the y:2, if you want to leave certain things to just use their 0 value. Go also has pointers, and so this p1 is a pointer to that p struct. And so if I modify x and then print out that p, it's now going to be 10 and 3 rather than 5 and 3. Or you can just print out the whole struct.
Wait, so what if you didn't use the ampersand? Would it actually go?
Yes, if I didn't use the ampersand, it would create a copy. So it's kind of the whole pass by value versus pass by reference, or copy by value, copy by reference kind of thing. And you'll see that more as I get into functions with structs and that sort of thing. So more about pointers. Pointers can be created by using the new keyword. So any struct you have, if you new it up, you're going to get a pointer back. And of course, you can use the short syntax instead of the whole var p pointer or point. Or you can just use the ampersand, in which case I could also initialize variables at the same time. So that's a really nice way of getting a pointer to a struct while initializing it altogether. So interfaces are the corresponding, I guess you could say, the counterpart to structs that give Go its object-oriented aspects. This error interface here is actually built into the language, which you can use for anything that is going to return an error. Certain parts of the language will use this error interface. So to actually implement an interface, if you want to inherit from error and say that you're going to represent some error, all you actually have to do is define your type and then implement a function which matches that signature. And you don't actually have to declare that you inherit from that interface or that kind of thing. All you do is actually implement the methods that match that interface, and Go sees that you are now that interface. So this function definition is a new syntax that you haven't seen yet, where you're declaring the type that the function is for, then the actual name and return value. So in this case, you have access to this error object, which I'm just saying is an int. And so when it calls the error method to actually describe what error occurred, I'm just going to return a string with that error code formatted into it.
Does that syntax allow you to put functions on types you don't own?
Yes, you can create, like it shows here, where you're kind of making a alias for the type int. I wouldn't call it an alias, I just can't remember the term for it. But you can only declare functions on your own types, but to get around that, you would declare your own type that is of that type. But that means the code you use, that say you had a function that you wanted to call on that, you'd have to first convert it to your type, and then you call that function on. Some more about errors. You kind of saw.
I guess that you mentioned that they were implicitly.
Yes, I mentioned that they're implicitly implemented. So that's another reason. One of the big reasons why they made interfaces be implicitly automatically implemented is that in addition to helping reduce the build time, they wanted to reduce the complexity of dependency management so that if you are depending on external dependencies that declare those interfaces, you don't have to have that hard dependency there that's going to cause you problems with versioning and all the other usual things you run into. So for example, here's an error that I've created as a struct that's going to capture some information about what happened when the error occurred. So I'm just calling that a login failure. In this case, I used a pointer because I didn't want to copy all of these values every time I pass that around. So the error is itself a function on the pointer type. So this type of pointer of login failure is not the same type as login failure. If I tried to call the error function for just a login failure struct, it's not going to compile. So as you can see down here, I'm actually going to return a pointer to that struct, and that's the error type that I'm going to return here. So this little login function, really buggy. Half the time it's just going to fail, and half the time it'll work and just return nil for the error.
Feature.
Yeah, it's a good feature to fail half the time. And then defer is the closest thing you could relate to it in .NET is the using block where you're going to dispose at the end of the using. Defer is a way to call something just when the function returns. It's the last statements that it's the last statement or statements that would be executed at the end of the function. So it's very common to use defer to close out files or that sort of thing. But you can also just use defer to just do anything you wanted to execute. So say you wanted to write out a header, and then right underneath that you can say defer write footer, and then continue on with the rest of your code for your function that's going to render that middle portion of your file. And then when it returns, it does that defer and call write footer, that sort of thing. But this is a common pattern you'll see here for getting both the actual item and the error from whatever function you call, and then determining how you want to handle that error, whether you should log it out, or maybe you're just going to pass that error on up the stack to some code that has better information about how to handle it, or whatever you want to do. But you can actually take that error and do something with it rather than having to do a try catch and all that stuff.
So if there is an error in opening the file, it's not going to call file.close because the defer is after?
Correct.
Return?
In this case, because the error is related to the open, if there was an error, it wasn't actually opened.
Okay.
So you don't need to worry about closing.
So you say the defer before you go do the code that you want to actually
Correct.
do.
Yeah. So in that case, it's going to close it, and the great thing about defer is that it'll still be called if there was an error. And when I refer to an error, I'm referring to panics, which are the errors that you can't just continue execution on.
Oh.
So there's two sorts of errors within Go. I'm not really using the right word when I say error, because in this case this one's more like an exception. You get the stack trace and all that sort of thing. But normally you would use an error because the code you're using, you don't want to just have to do a try catch and use exceptions as control flow and all that normal stuff. It's built into your logic to handle errors and respond to them accordingly. But when something happens that you can't continue operating with, or if someone just calls your function and passes nil to you, and so you're doing guards against the parameters passed in, then you can use a panic and just say this is wrong. So a lot of the panics could be caught at development time as developers are just fixing their code to work correctly. Another case where you would use panic is on startup. So you can check that certain environment variables are there, and if you can say if you're not even able to start up and run correctly, then you can use a panic to just fail. rather than a plain old error, which could be, which is just going to be ignored if it's not handled by anything. But with defer, what will happen is it's similar to a finally or a catch, where it's going to execute defers up the stack as that panic goes up. And so here I'm just doing an anonymous function. The built-in pattern is that you can use the recover function to get the error, and then you can decide if you want to swallow that error or continue to panic and go up the stack, that kind of thing. So that brings us to what makes Go really powerful, are what they call Go routines. And you can think of it similar to the TPL. The TPL stuff in .NET, where you can create tasks and execute them asynchronously and all that. With Go, you can just call whatever function you want, and if you use the Go keyword, it's going to be executed concurrently. So in this case, can anyone tell me what this would print if I executed this code?
So I don't like you currently. I don't like you, but I don't like you, but I don't like you.
Yeah, so it's actually only going to print I don't like you. And the reason it's only going to print that because this is executing separately and it's sleeping. So it's by the time it finishes the main function call, that Go routine is still running.
Yeah, okay.
So that brings the next part of Go routines, are channels. Channels are the way you communicate between Go routines or any kind of concurrent execution in Go. That's another case of the make function. Channels are always just declared as channel and then the type of object that you'd be passing through them. So C here is a channel for bools. I'm just using bool as a sentinel value to indicate when I've finished. So I'm going to pass that channel into my function that I'm executing concurrently. Then I'm going to wait for it to finish. And the way I'm waiting here is because I'm going to pull a value off the channel. So this little left arrow on this side of the channel means I'm pulling data from the channel. On the other end, when I'm done executing, I'm going to push a value onto the channel using that same left arrow. So you can kind of see that direction of the data flow to and from the channel. And that just makes us block here until we actually get a value back.
Is it really blocked?
Is it really blocked? So that's a whole can of worms because Go, if you look at the stuff in Go's documentation and the videos from Rob Pike, you'll see that Go is a concurrent language. And all of these constructs here are for writing concurrent code. It doesn't necessarily mean it's parallel code. Parallelism is something you can get on top of concurrent code, and that concurrent code makes it really easy to achieve parallelism. They don't necessarily mean the same thing. So the way he describes it is that concurrency is just a way to manage many things piece by piece. Parallelism is to do many things all at the same time. So with concurrent code, it could all be running on one core single threaded, and it's just going to run one piece at a time, and you have your logic separated out and simplified. Or you can then go run it in parallel. In the case of these Go routines here where you're waiting, at that point, this little piece of code would block or sleep or whatever to wait for that channel to have a value and unpull from it.
So if I understood what you meant by the difference between concurrent and parallel, which I'm going to watch the video, by the way. What the IEnumerable yield return pattern in C#, is that concurrent code but not parallel code?
Yeah, exactly. So yield return, there's nothing inherently parallel about yield return on IEnumerables in C#. It's just a way for you to specify that you're going to return items one by one as they're needed.
And you're jumping back and forth between two different pieces of code.
Correct. But then if you use that parallel.forEach or that .asParallel extension method, you could then parallelize that code, and then you would be moving through that enumerable in parallel. So at the end of these slides, I have a link to a video from Rob Pike where he goes into concurrency and Go routines. And it's a really good video to watch, highly recommended. And at the end of that video, he also has a link to another video where he talks about that whole concurrency is not parallelism thing. But his videos are always really good. So Go routines and channels, these are pretty hard to show on slides. There's a lot of really cool things about them, so I'm going to go to some demos. Before I do that, I'm going to be demoing using GoConvey as my test framework, which is a really nice test suite that handles running all of your tests and auto-washing your code for you. So as you're developing, you can do test-driven development and just automatically run your tests and build your code as you save your files. And it's very fast and very, very cool to see. So I'm going to show you that. And it's also really easy to get started with. You just, in your bash or wherever, switch to your project path. You go get, that's a command included in Go to pull down a package. And then you just run this package. And so in that case, you get something like this. So this is GoConvey running locally. And I am actually using the GoConvey code base as an example to show you a bunch of tests running because I wanted to find something that was of a pretty good size to show you how fast it can be before I go into my demos. And then it also has some really nice things like code coverage here, and you can see little graphs about what packages are covered and that sort of thing. You have a terminal window, not necessarily a terminal, but you have a log here showing what's going on. And say I went into here and put in a little build error here. It's going to, in here, just tell you right off the bat, build failure. It gives you information exactly where it was. It's not showing it now, but it was giving you links to the line numbers. And there's a way where you could click that link and it would open up in Sublime and take you to it. I didn't quite get that working. And there's also a way to do that with Vim as well. So you can just click the link and it opens it up to that line. It's exactly where the build failure was. And actually, it might have just been with a test failure. Let me switch this to be a failing test instead of just a build failure.
It gives you the line number.
And then there we go. So this link doesn't actually work for me quite yet, but it's a pretty cool feature. But you can kind of see I just saved that file and then it ran the tests after it recompiled the code. It tells you down here all the assertions and failures and all that kind of stuff. So it makes it pretty nice to do development and get really fast feedback as to what's going on. So I'm actually going to set this side by side. As you can see, it's kind of a little responsive design where it'll reduce these columns. Sorry for the flashing. And then the status bar down here will shrink down too. So let me switch over to mine. And of course, now it's not being friendly. Give me just a minute to get this set up right. Let me close this window. Okay, so we have GoConvey running here in the background. I'm going to go stop it from running the GoConvey codebase so we can run it on our own. So let me just switch over to this. I was just doing it in the plain terminal to kind of show you it can run here. So I just killed GoConvey, and yeah, now you get this little message. And if I expand it out, you'll see server down, so it can't monitor right now. But in my own code, I can actually just use this plugin in Sublime let's see, and I'm just going to run go convey from here. And now it's back up, and I actually have a build error right now because I have my first demo set up right here. All right, so for the demo, what I want to do, and I don't know why it's not showing both of these together. There we go. We're going to do a couple little exercises, TDD style, with Go routines. So this first one, we're going to write a test about a little test worker that we're going to run with a Go routine. And we're just going to make sure that when it completes, it tells us that it completed. So similar to that slide where you saw it wait for that function running in the Go routine. And when it finished, it came back. So the way you write tests in Go, you name your file _test to go along with your actual code file. You import testing, which is a built-in package in the Go framework. And then for Go convey, you can also bring in the convey package. The dot just makes it easier to work with because you don't need to qualify everything with convey. And then the other convention is that you prefix your tests with the test word. There's also a built-in benchmarking framework in testing, and then you would prefix your tests with benchmark to just write all the benchmarks you want to write. So you write your test. I'm going to say we're going to test that worker's complete. And then you just take in a testing.t parameter. That gives you access to all the usual things on tests. So you have the error, the fail, you can log, skip the tests, all that sort of thing. With Go convey, it's more of a BDD style kind of test. So instead of just using that t parameter, you can set up your story of what the test is going to do. So you could say something like, when a worker does some work, in the first convey, you just pass in the t, and then you can do your nested func. Sorry. And then from here, I'm going to maybe make a worker. That's just going to be a channel. And then we're going to say, let's do some work with that worker. So another great thing about Go routines is the select keyword. Looks very similar to a switch, where you have your cases, but it lets you write your concurrent code using multiple channels, or dealing with all the different concurrent things you would need to deal with, where you have many different things going on at once, and you need to figure out what to do. So, for example, we're going to get the result off of this worker because it's going to push a result onto that channel when it's complete. And in that case, all is good. Or maybe let's say something like, let's assert that we got back the result where we were expecting. So the other thing convey brings in, besides the convey function, is the so for all the assertions. So you can say so the result should equal, and let's just say it should respond back with a little string saying it was done. So let me save that, and we still have a build failure. Undefined do work. Select statement must have receive on right-hand side. So I actually missed the receive from the channel. So we fixed one builder. We still need that do work. But first, we haven't really finished up our test, because what's going to happen is if that worker never responds, we're just going to get a deadlock. In fact, let me do that before I finish up the test. Let's go implement our little do work function. In fact, let me use that little snippet. Okay, so just going to do work, and if I remember right, we took in a channel. So we have that worker, which is just the channel. Another cool thing you can do with channels in Go is you can specify whether you're going to be pushing or pulling from the channel to help the compiler make sure your code is correct. So in this case, this do work function is only going to be writing to the channel. So I'm saying that I'm only pushing values onto the channel. And then if I try to read from the channel, for example, if I tried to do this and I try to compile that, I can't receive from a send-only channel. So the compiler is actually checking that for you and helping you make sure you're running it correctly. In this case, let's not do anything. So it builds. Now we get a failure, and it detected a deadlock. And the reason it detected a deadlock is because we're trying to read from a channel right here, but nothing is ever writing to that channel. And so the Go runtime can actually analyze your Go routines in your channels and detect when you run into those deadlock situations. So let's say we want to make sure that this test completes in a reasonable amount of time. So what would happen if I go and import the time package and we're going to sleep for a couple seconds, and then we'll tell the caller that we're done. That's actually going to make our test pass, but it's slow because it had to sleep for 2 seconds. Can everyone see this? Or okay, because there's a light thing as well. I'm not sure if that's easier to see. I just wanted to show off that setting. They've made this UI really nice. They have a lot of cool things in there. But so what we can do with this select, it's kind of pointless to have a select with only one case. Let's say we want to say that the worker should take at most 1 second to complete. Well, there's actually something on time we can use. So let me import time here. And now what's going to happen is that this select block will execute whichever case it gets a result from first. So it's going to be pulling from both channels at the same time. Whichever one gives it a value first, it'll execute that case. So in this case, we could just use that test parameter to say that there was an error in our test because we failed. The reason I'm using T rather than so is because I didn't really see any kind of so we failed. It's like we know that the test failed, so I'm just saying T.error. There's not really any kind of assertion that I need to do.
I feel like you could read that. So the result should equal
result should equal finished. Yeah, result here is just a string, so I'm just saying so this string should equal this string. It's kind of meant to be like a sentence kind of thing.
So what happens when you hit that select and those channels have values?
In that case, they say it's non-deterministic. It'll pick one. I would hope that they would do it in order, but they don't guarantee that. They're just going to pick one. You can also add a default case, and in that case, it won't wait for one of the channels to have the value back. It'll just execute the default immediately if none of the channels return anything. And you can just say default and then do your usual code. So that was kind of slow because it's waiting a whole minute, and so Go convey is supposed to be really fast. So let's make our code actually work correctly. Let's say I just use that, comment it out, and hey, we have a build failure. Imported and not used time. Okay, so let's get rid of that guy. For now, I'll just comment it out, save, and it passed. That's pretty quick. And then with Go convey, it kind of gives you that little tree of how you set up your little story or your test cases. So you can kind of nest these conveys and have multiple conveys, however you want to group your test together. So that's a pretty simple one. It's pretty much the same thing from that slide. Let's do something a little more complex, which will kind of demonstrate some more power of Go routines. To get me set up to that point, I'm actually just going to switch over to that. Okay, so look at that. Build failure right off the bat. So Go convey, saw the files change, compiled and ran that, or well, didn't even run it, just compiled and build failure. As soon as I hit that, it was so fast you almost didn't see it. And the reason it's failing is because I have another blank test here where we're importing packages yet, and our little demo is empty. For the sake of time, since we're running a little short, let me fill in the test first. If I can remember what I named that. Okay, here we go. So now we have a test. It still doesn't build because we're referencing some things in this test that we haven't created yet. But what I want to test is that we are creating a pool of workers, and for this worker pool, I want it to balance out the work that it divvies out to the different workers. So I'm going to say that, yeah, I'm sorry. Let me open up one that actually makes sense. There we go. So our implementation is still empty. Here's our test where we're going to create a worker pool, and we're saying we want 5 workers in it. This is going to give us a pointer to that pool. Then we're going to loop through 20 times and just enqueue an item onto the pool's queue of work. In this case, it's just an int, but you could imagine that that's a struct that contains work to do or whatever. Then we're going to use a construct in Go called close that will close that channel. In which case, it'll notify those that are reading from the channel that it's finished. And then we're going to assert that the work performed on that worker pool gets balanced among the 5 workers. In order to do that, I'm just going to loop through all the results, which is another channel, and then throw onto this little map I've made which worker completed that, and just count up. So the range keyword actually works on channels as well. And it'll just continue to read from the channel until that channel gets closed. And then to actually assert, we're just going to loop through that map real quick, ignore the key, just use the values, and make sure they all equal 4, because 20 items across 5 workers should be 4 items per worker. So I guess the first thing we should do is actually make this little new worker pool function so we can get this to build. So we'll create func. Let me use that snippet again. I keep forgetting about that. There's a lot of cool code snippets in the Go Sublime plugin that I'm still discovering. So we have that new worker pool function, and let's see, that took in just an int, right, of the number of workers. So we'll call that worker count int, and we're going to return an actual worker pool back. And there we go. That's great. We still fail to build because we don't have a worker pool type. So let's say type worker pool. it's a struct. And our pool needs the workers that are within the pool. So that's going to be a slice of workers. It had that queue, which we were pushing values onto, which means we're going to make a channel that is receive only or send only, because we don't want people reading from the queue. We only want people to add values to the queue. And on the other end, for results, you can only read from that channel. And that will be a result type. So let me save that. Well, now we don't have worker or result types defined yet. So let's say type result. That's also a struct. The result will just say what worker it was. I'm just going to give the name. And then maybe we'll say what job it completed. And then we'll declare our little worker type. And it's just going to have a name so we can identify them. Let me clean that up a little. So, yeah, thank you. So let me save that undefined workers. Now we're missing the return. I'm also going to change this to be a slice of worker pointers so that we're not having to copy that worker.
You're right. If you're doing only a write-only queue, how does the range go through it?
So this here with the, are you saying like how am I going to read from this queue?
Yeah.
So this just shows what it appears to the outside world, you could say. And I'll kind of show you, I'm actually not going to be referring to this queue field on this struct when I'm actually reading from it. So that's the next thing we need to implement. We need to implement this new worker pool so that we can return it. So let's go create a worker pool. Except we need workers queue and results before we can return that value. So what we'll do is we'll create that queue, and that's going to be chan events, and we'll create our little results channel. And as you can see here, I think this answers your question, Zach, but the this queue here, all channels are bidirectional. It's just how you refer to them, whether or not they're read-only or write-only or both. So I'm going to be using this queue, not the one from the worker pool. That's just what I'm going to return to the outside world. So that was a chan of results. That's great, but we need our workers.
Should we run the test?
Right now it doesn't build, so we're making it build, and then we'll make it fail. And then once this builds, and then we see the test failing, then we'll make it pass. So we're going to make a little slice of workers, and we know how many we need. So we're going to pass that in. And then to fill that, we just need a little loop in order to create a worker. And the worker needs a name, so let's see, we need to import thumped. And then we can say our workers are just worker numbered. And I. Okay, so we have our worker here. Let me scroll a little bit so you can see that. Now let's start off our little do work function for each worker. So we're going to tell this worker to actually do some work. We're going to give it the queue that it needs to use to do its work and the results channel that it needs to put its results back onto. And then we'll actually populate our slice with that worker. And then let's see if that builds. Not quite yet, because can I use worker type worker as type pointer worker in assignment? So let me fix that. Now it's a pointer. I also didn't update the pool to actually pass those things in. So here's the queue. Oh, sorry, I need the workers first. Workers, queue, results. And then that last build failure was that we haven't created do work. So let's make do work up on this worker type real quick. Func w worker do work. And we were passing the queue, and that queue is a read-only channel. So the workers can only do queue items from the queue. So we're kind of using that to help us with our making sure our program's correct just by compiling it. And same thing with the results channel. We're going to say that we can only write to that channel from the worker. So let's see, how are we going to do some work? Let's just say we're going to read from this queue. Actually, that's the first time I've ever done that. Let's simulate that we've got some work to do, so let me import that time package again and just do a little sleep. And we'll just do only a short sleep here. And then when we're done pretending to work, we will actually pass for the result on here. So we're going to say that this worker completed it, and the job we finished was just that item pulled up from the queue. So, does it build? Not quite. Undefined results on line 20. Yeah, okay. So save. Looks like the test is running, and we have a deadlock. Can anyone tell me why we might have a deadlock in here? So we actually have a worker here that has been trying to read from the queue. And it's kind of hard to see, but it does show a little line number here, line 14 for the deadlock. I believe that was line 14. Nope, it's in the test. Okay, so right here, it can't push an item onto the queue. And the reason it can't push an item onto the queue is because there's nothing that's trying to receive on the queue yet. So when you're setting up channels in a concurrent manner, a lot of times you won't necessarily be reading or writing from the queue at the time that it's going to get into that little blocking operation and wait, and so then you're stuck, and so it'll say it's a deadlock. So what you can do is when you create your channel, you can specify the channel's buffer size, in which case you can push up to that many items onto the channel before reads or writes will block. So if I think I just saved it and it ran it, but maybe not. Yeah, I couldn't tell. Now we do have another deadlock at this time down on line 20 in the test. So we're trying to read from the results. And the reason we have a deadlock here is we're trying to do a range over the channel. And at the point of it finishing reading all of those results, there's nothing else on the channel. There's nothing that's writing to the channel, and it's just waiting forever. So it sees that it's another deadlock. So we haven't closed it. We've closed the queue. How do we close the results? How do we know that we're actually done doing all the work from our queue? Well, Well, this is where you can use other channels to help with signaling between different pieces of your code. So we're going to signal between the worker pool and the worker. What I'll do here is I will create a little complete channel. And since it's just a little signal, I'm just going to say it's a channel bool. And then what we can do is we can pass that channel to the worker so that it can signal when it's finished reading from this queue. So we close that queue channel from the test, and we've told it we're done giving it work to do. So this loop will return and finish when that queue is finished. So then at that point, we can just say we're complete and signal. Now we have a little undefined complete. Yes, thank you. So that's a channel bool, and if I wanted, I could even say that it's a write-only channel, because all we're going to do is pass true to it. And we still have the deadlock. Demo test code line 20. So that's the next step. Is we've signaled that we're complete, but we're not closing the results channel yet. So the worker pool now has a way of being notified, but before we return this worker pool, we need to have some way of closing results. So we can actually just use another Go routine. And the cool thing about Go routines is they're very lightweight, so don't be afraid to create another Go routine. In this case, I'm just going to make sure that I got a complete signal from each worker. I know I have a certain number of workers, so I can just read from that little complete channel. When all the workers have said they're complete, I can then close our results channel and build failure. Oh, yes. So if you notice here, I gave Go a func. It's an anonymous function to execute, but I didn't actually execute it. So look at that. We have a passing test. And you can kind of see Go convey has the little nice flow of given that, when this, you can do multiple assertions and whatever. So that kind of illustrates a little bit of the power of Go routines and that sort of thing. It's once you get into them, they look really promising.
Good question about your worker pool.
Yeah.
Are your 5 workers all doing the same work?
Yes, these 5 workers are all reading from the same channel.
So like you set it up some way to distribute the work across.
Yeah, and I kind of, this is a little contrived, but I basically just had each one sweep the same length of time. So they're just going to get them one by one, round robin style. In a more realistic scenario, if they're taking different lengths of time to complete the work, then whichever one is ready to get the next item from the queue would be the one that takes it. So it might not necessarily be balanced. But
Is it true that when one worker consumes one entry from a channel, or when the channel pushes, that the other worker that has a reference to the same channel, when it consumes, it's not getting the same one that the other one's got?
Yeah, so the question was, if one worker reads from that channel and gets an item, other workers won't be getting that same item. And that's the great thing about Go routines and the way Go is meant to be concurrent, is that all this stuff is, all this concurrency and the locking and all that kind of thing is all taken care of you by these Go routines. So you don't need to worry about synchronizing that channel and making sure it's locked before you write to it so that no one can read from it at the same time and all that kind of thing. It's just going to be handled by the Go routine, and then as something reads from it, it would get the one value. The other workers would then continue reading and get the next values, but they couldn't get that exact same value unless you added it to that channel multiple times. Thanks to the way it's concurrent, there's no way you could have race conditions that you're reading. So you have 2 things reading the same value that shouldn't have, or that kind of thing.
So package management is part of life, right? So how do you, like for NPM or like specify versions So how do
Mhm.
you do that?
So at the moment, I don't think they have an answer for that for
I can
version.
answer that.
Can you
Okay.
show?
So they're not planning on actually building that language itself. The open source community already has like 3 different options you can use. I've actually spoken with a few people that have used this pretty regularly, and they actually try to stay away from those things that are locking down versions. Obviously, if you're like compiling and then you try to deploy 2 weeks later, you run into the risk that the packages are going to change, but hopefully, within a tighter time span, that's not the case. But there are, I mean, if you need it, there are options available.
Yeah, there are open source tools, and that's kind of been the answer for Go for a few other things. Is the answer to this will be solved by the community, but with tooling and that kind of thing.
Yeah, I mean, there's something similar to Bundler where it'll actually pull those packages into the project directly under another directory.
Right, and store them locally.
And that way it's all open, so-
And they kind of said in their spec they intentionally left these import statements as a string only, so that you could kind of build on top of it and throw whatever into that string you needed to, so you could add in version information or that sort of thing if there were other tools that were going to read that differently. So let me get to just the last few slides before we finish up. And they were over here on this little window. So the kind of the last thing about Go is that it's not just a language for back-end concurrent execution. There's a big open source community with a lot of momentum for creating web frameworks and other applications with Go. These are just a few of the web frameworks out there. These 4 seem to be the most popular from what I could gather. Corey and I have looked at Martini and Revel a little bit. So Martini is similar to Sinatra, hence the name. Revel is more of a Rails or Play style framework, more heavy-handed. I think Martini is the one that's looking the best at this point, since it's following the Go idioms the closest. But it's hard to say, and there's a lot of people out there starting to say that you don't really need to use a web framework. You can just use a lot of the built-in functionality in the Go framework with HTTP and JSON support built in to just write your own web app without a framework.
Yeah, it's like, it starts out with what they call an HTTP camera truck, and you basically register your routes with that truck, and you're given the opportunity to get in a that particular route. And a lot of people are saying is that you don't need a framework because there's middleware and everything just using that camera truck. And all of these frameworks are just kind of slowing you down. Because, like, as an example, Martini looks awesome from an API perspective, but their execution is all done by a reflection. And he'll say, well, it's only a small, performance degradation. But then when you look at the benchmark tests against it versus every other framework out there,
Corey, do you remember that URL?
just search for Martini.
There was a
Slowest out of all the options.
Say search on.
So it's big enough.
there was a GitHub project.
Benchmark. Second one down.
Oh, yes. So he wrote a benchmark. Are you sure that it was this one? Yep. This doesn't quite look the same, but he kind of took a bunch of different frameworks out there, and the other one we were looking at had more listed here. It was the routing benchmark. Let me search for that real quick. Go routing benchmark. Yeah, this was it. So he was just benchmarking just routing of HTTP requests to the different URLs and all that, and looking at the different ones that different web frameworks use, like Martini and some of these other things used by other frameworks, and just looking at the HTTP router where they kept performance in mind and tuned it very well to make sure it's going to run quickly. The benchmark itself had to run it 100,000 times just to be able to measure how fast it was. that benchmarking built into the testing package will just increase the number of iterations until it gets to a point where it can measure the speed. And so you can kind of see the speed of this one versus the speed of something else, and how many memory allocations it's doing per operation and that sort of thing. So Go is meant to be a fast language, but you also need to remember that you build on top of fast components and tools, and so you want to look out for things that are going to help you do that and help you to remain speedy. Does anyone have any other questions about Go?
I have one. Can you demonstrate tabs versus spaces and maybe some brace layouts?
Sure, yeah. So let me keep Go convey here so you can kind of see what it's going to do. Sorry, I'm getting my shortcuts messed up. So built into the language, it even cares about that. So if I try to save this, it won't build if I move the brace to the next line. So they're very particular about placement of your characters. Also, Go Sublime, when you save the file, runs Go Fumpt. Fumpt is their abbreviation for format. And they actually have a tool called Go Fumpt that you can run across all your code. So every time I save the file, it's going to actually format the file for me. So you kind of noticed, you might have noticed as I was writing stuff here, and maybe I have the indentation wrong. If I save, it's going to format everything for me. And even if I'm telling Sublime to use spaces down here, and I actually go into here and I convert everything to spaces. Ooh, this is going to be really hard to see. You can see the little dots here with spaces. As soon as I save this, it's tabs again. And that's actually in their FAQ. There's a question about tabs and spaces, and they say Go Fumpt just uses tabs. We'd recommend it just use tabs. Try to avoid using spaces. And I always just thought, if they're going to take care of it for me, I'm just not going to worry about it. I'll just let it be tabs. It's not that big a deal. Great. So go watch the concurrency video. It's really good. And this free Go book is online. It's an interactive book online with exercises built in. It's really good as well. Thanks, everybody.